Okay, thank you everybody. Welcome to my talk, GraphQL versus the traditional API. So after some technical problems, we can start. First of all, let me introduce myself. My name is Vladimir Dejanovic, and I am part of professional IT scene since 2006. In other words, I'm getting paid for work that I do since 2006. I developed programs in many programming languages, many technologies, frameworks, all kind of things. Also worked on different types of projects over the years. Also, I'm the founder and leader of Amsterdam Java user group, and I'm a speaker at conferences giving technical talks. So, what this talk is going to be about. First, I will spend some little time on REST, what REST is, and to be more precise, what traditional REST API are. After that, I will spend some time on GraphQL, basically explain what the GraphQL is, and then most of the talk I will spend in comparison between traditional REST APIs and the GraphQL. If you have any questions, please wait until the end because I have around 200 slides. So, I get server in request, so the server can respond to the client's request. Code on demand, well, this is optional, and actually it means that the server can send some piece of the code to the client and the client should execute it, but this is optional, so most REST APIs don't actually do this. And the last but not the least, uniform interface, and this is basically the big part of the REST. And well, in a nutshell, what it means is that the different parts of system can develop independently. Again, if you would like whole dissertation and much more information in detail, just follow this link. Basically, it's publicly, it's online, so you can read the full dissertation if you want to. It's a very good read. Okay, but when we say traditional REST API, what do we mean? In most cases, it means that we have some database somewhere. We have some application which actually is talking to the database, so it can retrieve the data from it, change the data, do whatever we want. And of course, we have a user who actually talks to our application, which then talks to the database, fetches the information that it needs, send back to the user. Sometimes it's basically like pair field, so exactly how it looks like in the database is going to be also sent to the end client. But again, it can be much more complex. You can have multiple databases, you can have other APIs, you can have other systems. But for this presentation, we're going to stay with this as very simple and stupid example. So, example that we're going to look into is like this. It's simple block, something that we should all more or less know and understand. Of course, we have author, and author has an ID and a name. Then we have a post, of course. Post has ID, title, body, and author ID, ID of the person who created it, right? And this is going to be a little bit more complex post blog, so it's actually also to have comments. So we have advanced feature of comments, and comments, of course, has ID, text, ID of the post to which it belongs to, and ID of the author who created it. All the examples that I'm going to show you are going to use Spring Boot and MongoDB, and for a very simple reason, because I'm lazy, and Spring Boot gives me a lot of features for free, so I don't have to type a lot of code. It just does the work for me. And I'm also using MongoDB again because I'm lazy, and it can handle very not correctly formatted text, and I don't have an overhead of table schemas and things like that. So that's the only reason why I'm using this. A little bit of warning, the code that I'm going to show you isn't production ready, so it's basically very stupid code, but again, the whole idea behind this code is just to show some points, not to actually to take this and put it in production. So that's why this slide here. So let's look at some code, right? So oops, this is not good. Just a second. My bad. Space arrangement error. Okay. It's big enough for everybody? In the back, you can see it? Okay, cool. So, first of all, let's look at our POJOs. So we will look first at simple REST API. So this is the one. So basically we have an author, simple POJO author, right? And exactly the same like table. We have an ID and we have a name. Of course, POJO isn't really useful until actually we can read the data from it. So we have author repository. So we have author repository. And again, in this case, we are using Spring Boot and everything, so we can just say, okay, extend Mongo repository, and then it will automatically know, okay, I'm using MongoDB, I will know how to connect to the database and do all the other stuff. And all we need to do is say, okay, like we're using the Podger author. And that's it. Spring Boot will do everything for us automatically. So that's why it's so nice. So if we look into our controller, okay. Oh, no, wrong one. So it's, again, very simple code. We say we use REST controller, and we expose some endpoints. We have endpoint/authors, which is going to return the list of authors. And also we have, okay, endpoint/authors ID, which is going to return us the single author for that particular ID. So let's then look at posts. Post, yep. So post, again, very simple. Just Pojo, ID, again, author ID, title body. Exactly the same like I showed you basically on a slide. Again, post also has a repository. And again, what we can do is we can just curl HTTP, right? Host, authors. And we get nice look at authors. We can also do the posts, right? And we can get the full list basically of posts with all the fields. So how you can actually create very simple front end for this one is when somebody comes to your blog post, you first hit the endpoint for posts, you get all the posts, then you show them, and then if you use, for example, click on the post, then you want additional information, for example, author ID. In this case, we don't have this information, so we basically need to take author ID from here and hit the endpoint authors, provide it with author ID, and then we get information about the author. Okay, but what if you want to show the comments? Well, in this case, we need to go take the ID of the post and hit. And so to answer this question, let's go a little bit in history. And it goes very simply like this. GraphQL was developed in Facebook in 2012. And it was built internally, and it was only an internal project. And like every internal project, it means that there was a need to solve a certain problem. And the need was so big that they wanted to solve it in one place and then propagate it throughout the whole company so that not everybody has to do same work over and over again. Luckily for us, they said, okay, let's make this publicly available in 2015. So now all of us, what the hell that means? After you understand GraphQL, then you understand also the sentence, but that's not really the best, right? What you need to know and to understand is that GraphQL is a specification. Nothing more, nothing less. It's only a specification how something needs to behave in order that we can say it's a GraphQL. But we as developers, we don't work with specifications. We work with implementations. Is that implementation maybe didn't implement all the features of the GraphQL. So again, when you work with some implementation of GraphQL, be very careful to know what's implemented, what's not. What can be used, what can't be used. But again, like talking is boring, right? So let's see some code. Okay, so let's go back to Eclipse. Let me first kill this one, or I will not be able to start other codes, which will not be very useful. Okay, so here I have a simple example of a GraphQL. And with the GraphQL, the most important thing is basically the schema. Everything starts with the schema. And the schema is used basically for a server to say, okay, like this is what I understand, this is what I can handle, and also this is sent to the client, so the client can know, okay, like this is what you can send to me. If you don't send me something which is according to the schema, I will not do any work. First, you define the types, and basically here we define type author, and it's very simple. We have the author which has field ID, type ID, and I'm not sure if you see it good enough, but there is like exclamation mark, which actually says this field is mandatory. So if we put for some field that it has to be mandatory, in every request that's actually going to have this, it has to be there. If it's null, it's going to crash because it's mandatory. Again, author has the name, has a string, of a type string, and again, it's also mandatory. So you can see this is exactly the same like the table that we defined in basically the database, and exactly the same like Pojo. So like it's very simple, right? No magic or anything. Again, we have type post, and again, exactly the same. Like the Pojo that they showed you, and basically the database. We have an ID of the type ID, we have title of type string, we have body of type string, and we have author ID, again of the type string. Similar for the comment, we have ID, author ID, post ID, and text. So nothing really groundbreaking at this point. Then we come, okay, let me just put this up so you can see it easier. Go up, yeah. Okay, so everybody sees this, right? So you have a schema, and this is basically the heart of the GraphQL. When the GraphQL starts, it's going to basically look for this one, and it's going to, from there, build everything else. And here we say we have a query, and it's of type query. In GraphQL, you can manipulate basically the data in different ways. The most basic one is, of course, read. And with a query, we say we're reading the data. You can use whatever name you want here. Basically, GraphQL wouldn't really care that much. But again, for your colleagues and anybody who comes after you, please use the standards so that everybody knows what it actually does. And we don't have to decipher, OK, what is John Doe means. So if you say query, everybody knows it's only reading the data, read only. We define here type query, and we say, OK, all posts, and it will return array of posts. OK, but this is the schema, how the Java code looks like, basically. OK, let me show you. So first of all, OK, let me close this one. First, let's just look quickly at the Pojo. So the Pojo, exactly the same like in previous example. Every single line is exactly the same. So no differences. If we go to the repository, again, exactly the same. No difference. And now actually the fun parts come. Basically we have here, oh, I was showing actually the wrong code. My bad. Yeah, but again, believe me, it's exactly the same. So yeah, you see.
Before it was, yeah.
Yeah, but you see, it's also, again, it's also the same. So there is no difference there. The difference is basically here. We create this class, GraphQL entry point, and what I'm doing here is I'm extending simple GraphQL servlet. And again, I'm lazy and I don't want to do a lot of work. So I choose this approach because the library, basically the Java implementation of GraphQL, does a lot of work for me. All I need to do is in my Spring application say, OK, register this servlet. Basically, here I say, register this servlet and register it on this endpoint, /GraphQL, that's it. And then we go back here. So our GraphQL entry point extends simple GraphQL servlet. In constructor, we are going to call this private method here, and it's going to do actually the whole work. So what it's going to do is basically take schema parser, take new parser, and here it's going to take the file where I define this GraphQL schema. So this is basically how it will know what to do in its internal logic. Then I say here, OK, add resolvers, and I'm going to add resolver named query. And again, this name has to be exactly the same like the name that I use in schema. So that's why I also say like use standard names, because it's going to be easier for everybody to follow your code and schema definitions. Afterwards, you just say, OK, build, make it executable, and that's it. OK, but what query does? Let's take a look. Query, all you need to do is implement GraphQL root resolver. That is all. Everything else basically depends from what I defined in schema. In my case, query has all posts, which is here a very simple method, and it's returning the list of posts. That's it. So how it actually look? Okay, so let's start this code. So if I go here, It's still not up. Come on, be faster. It should be up now. Again, a very nice thing about GraphQL is that it's very simple, that you can add one very simple file, which is going to give you this. And one thing here that you can see is that first you get the whole documentation of your schema. And like I said, when the client connects to the server sends to him, okay, this is my schema. This is basically the GraphQL schema, and according to that, it knows then everything. It can create the documentation, but also here I can do, you see, autocomplete. So I can do query, and like we said, we can do the query, we have all posts, and then from all posts we have ID, we have title, we have body, and we have author ID. And here's the response. So exactly the same thing like in simple REST API, right? But let's be honest, like, okay, this is not really that a big deal, right? We already had this one, so what's the point? Well, one nice thing is that you can do something like this. You can select, okay, only ID and title, and now you have exactly got what you said. So you can do the filtering on the response. But again, let's be honest, this isn't really the groundbreaking thing. You can do this yourself very simply. You can just add functionality to your API and do exactly the same thing even without GraphQL. So let's go a step further. Go away, Siri. So now I changed the version, and let's just build this code so that we don't have to wait later. So what's changed now? Okay, no, I don't want it, go away. Don't save. GraphQL, where's my schema? Resource, yeah, schema. Okay, so what basically changed here is inside the post, I removed the author ID and I put this. I put field created by and said it's of type author. But I'm not going to change any POJOs, any repositories. All of that is going to stay exactly the same. So how it actually our code is going to work? Well, if we go, okay, let's close this one. So we go back to GraphQL entry point. The only thing that I need to add is basically this line, post resolver. So in the resolvers, I'm going to add post resolver. That's it. And what the post resolver is going to do is, okay, open the code, hopefully. Then it refresh. Refresh. Okay, so. Where's my? I hate this. Okay, so here it is now. So we have post resolver. And in this case, we say post resolver implements GraphQL resolver. So if you go back to the query, here was root resolver. Here is GraphQL resolver. And you're going to see we have this here, which actually says, okay, you're a resolver for the type post. So whenever I'm handling the type post, and I need some fields which are not part of the POJO, go inside this. And this class should actually know how to actually deal with it. And if we go here, we see here, okay, we have field created by, actually the method that we defined in the schema. It's taking the post as argument and sending back the author. Okay, but what does it actually that means? Well, let's look at when it starts running. Up and running. So important thing that you need to remember, if you change the code, you change the schema, you need to restart the client, or the client will not know about the changes in the schema. So now here what I can do is I can say created by, and I can say name. And if I see here, and now I get basically the name of the author. So in this case now I'm giving basically to the client ability to select, okay, not only what fields he wants, but also, because you know there is connection between the post and the author, I can also give him basically ability, okay, do you want information about the author or not? If you want, which kind of information you want from the author? So we're giving the client much more basically rights and ability to do and the power. Okay, so let's go even one step further. Because again, this is nice, but not that nice. Okay, so let's go back here. So what we did now, just refresh, just to be 100% sure it's going to show everything. So now I also changed the author, because we know that one author can have multiple posts. So basically we said here, okay, like one author has a field post and its array of posts. Posts also have comments. So here we actually also said, okay, post, comments, array of comments. And also then comment can be created by author, exactly the same like the post can be. And the comment belongs to a certain post. Inside the code, basically, we added two more resolvers. So we added author resolver and comment resolver. Again, if we go into author resolver, again, implements GraphQL resolver, type author, has method called posts, argument take author, return list of posts. Similar thing for the comment, similar thing for the post. So I will not be showing you because it's more or less exactly the same code. But what that now means is that if we start this application, okay, so I'm here. Let's just restart it so that we basically take the new cache. Okay, so now we have a post. For post, we can ask for comments, right? Text. Then we can say created by. Then we have name, right? Then we can ask for post from the author. Then we can ask for title. Then we can ask for comments. And we can go with text, right? So we can do something like this, and we get very crazy response. So we can really go nuts here. And again, if you take a look here, I have here comments, which means that I can go with this loop basically to forever. And of course, at one point, my application is going to crash. So we gave a lot of power to the clients, but we also now exposed ourselves as a building of a backend to much more abuse, which isn't really nice. So what can we do for that, right? So, well, there are multiple ways that we can protect ourselves from the abuse. If I just find the right slide. Yeah, this is the slide. So basically, this was more or less what I showed you, like comments. So how can we protect ourselves from the abuse? Well, one way that you can protect yourself is basically giving the timeouts. And say, okay, like if certain request is going to take more than a certain amount of time, I just send back to the client, okay, like go away. It's simple to implement, but does it really solve our problem? Well, not really, because we're still going to process the huge request from them, which is not ideal. The other way that we can also do is we can limit the maximum depth of the query. Because again, like if you remember what I said at the beginning, client sends a request to the server then checks the query according to the schema, is it correct or not. At the same time, we can also check, okay, is the depth good enough or not? If its depth is too big, just go away. So this is a little bit more, again, it's not really that difficult to implement. It's going to protect us much better than a timeout. But again, it's not going to protect us from all the use cases. Because again, client, if it's really abusive, they can basically attack us in the width, so instead of the depth. So we can still be attacked very heavily. So the other thing that we can do is say, okay, we don't care about really that much about the depth. We care about the actual maximum complexity of the query. So then in this case, for every query, you say, okay, this is the complexity of this query. And then again, during the processing of the query, checking if the query is correct according to the schema or not, we sum all the numbers and say, okay, like this number is, for example, like 10, and we allowed maximum query complexity of 8, so go away. This is a little bit more complex to implement, but the problem with this one is then you need to actually score every single query. Again, in the beginning, it can be easy because you're building it, so you know more or less how complex it is. You give a score. But we all know that code lives for a long time, which means the code is going to change, things are going to evolve. Are the scores going to stay the same or not? Probably not. Will the people who are actually going to modify the code remember to actually update the complexity and will know how to do it in correct manner? Probably not. So it's not really ideal. Another way that you can actually protect yourself is by throttling. And actually for every client you say, okay, this amount of CPU or time or memory or whatever I'm giving to you, and that's it. And I'm giving to you this every second, every few milliseconds, every minute, depending on your use case. This is the most complex thing to implement, but it's going to protect you from the most cases. Again, if we go back to the thing from the beginning, when I said the GraphQL is only specification, some implementations of GraphQL already have this. Some of them have parts of it. So again, be very careful when you choose implementation. Look, what of this is out there, what is not. Things which are not there, you have to implement yourself. So it's not really everything for free. Okay, but so far we were only talking about reading the data, but if we can only read data, that's not really that fun, right? At one point we want to change the data. So what do we do then? Well, mutations come in place for that. So let's look at the code. So GraphQL, like I said, already has, which one? Oh yeah, I need to close this one. So GraphQL has queries when you want to read the data, and when you want to change the data, you have mutations. And again, it's not very different from the queries. Let me just refresh this one. Again, everything starts with the schema. So in the case of the schema, let me just bring this one up so that everybody can see it. Okay, so this is our schema. Here was the query. Now we added one more, mutation. Again, you can put here whatever name you want. But again, please be thoughtful about the person who is going to come after you. If you put something crazy here, they will not know. So use mutation. Again, you define type mutation. You say add author, which actually is going to take parameter name of the type string, which is going to be in this case mandatory, and is going to return back the author. Again, we're also going to be able to remove the author by providing the ID of the type ID, and again, we're going to get back the author. So this is the change to the schema. How our code is going to change? Well, not that much. In a GraphQL entry point, let me again put this one up so that everybody can see it. We just add one more resolver, mutation, that's it. And what mutation actually does is, if we open the code, mutation implements GraphQL root resolver. So exactly the same like query. Query was implementing GraphQL root resolver, and mutation is implementing the GraphQL root resolver. And again, in case of mutation, we have a method called add author, which takes parameter, basically name of the type string. It's going to return the author. And also we have remove author, which is going to take ID of the type string and return the author. So if we just, oops, I'm running the code already. That's fast. So if we go back here, okay, so let's remove this crazy query because I don't want to kill myself. Oh, it looks like I didn't restart the code. Or, oh, I didn't compile the code. My bad. Yeah, I need to compile the code, sorry. Tests. Sorry, my bad, I forgot to compile the code. I just started the same version like before, which is not really that fun. Okay, so it's up and running. So if you go back here, okay, so now we can have, I also added the all authors so that we can see basically all the authors which are here. Yeah, name, wait, that's it. Okay, and I need to close this one. Okay, so I run it. I have two authors. Now if I call mutation, add author, name, and let's say ID. We created the author, and if we go back, authors ID name. Now we have one new author. That's it. That's all that you need to do for mutation. It's like it's very simple. Not really any groundbreaking work. Okay, so let us look at some other stuff. So the GraphQL, like I said, can do multiple things for us. It can actually do reading the data. We can also change the data with mutations. But there's also one more nice thing, which is called subscription. And the idea behind the subscription is that you get real-time updates. So basically, you use the same approach as we use for acquiring mutations, but we just say, for this type of information, for this field, just constantly send me updates. And these updates are going to come in real time. And again, if you think about that GraphQL came from the Facebook, you can immediately see what their use case was. Okay, I have a mobile phone, and I want to get info and updates about my people, basically sending likes, posts, all those kind of things. So you need something like this. The problem, unfortunately, with subscription is it's not supported by all implementations. So that's what I said. Be careful which implementation you're using. For example, the Java implementation which I'm using doesn't have subscriptions. So if I would like something like this, I would have to build it myself. And it's not really that fun and easy. Okay, so again, first thing I saw when I saw the GraphQL, I saw it's very cool because I give to the end users a lot of power. But then again, they can abuse my basically API a lot. So how actually I deal with them? And again, one thing that I was thinking, okay, I need caching, right? Because we all know if we don't have caching, our application is not going to really perform that well. And in the case of a simple REST API, it's not that difficult to actually do the caching. There are a lot of tools out there which are going to do for us. So if I just go and open, again, simple REST API, in this case, all my access is going to basically from for the service. So all I need to do basically in this class here, I just add cacheable annotation, and that's it. And Spring is going to take all the caching for me automatically. But in the GraphQL, basically I don't know how the user is going to come to my end class, because like in this case I know exactly it's going to hit one of the endpoints that I made in controller, then the controller is going to call the service. So I'm in full control of how the user is going to basically go. Full life cycle. In the case of GraphQL, as you saw, it can go all over the place. It's going to basically hit the GraphQL endpoint, but then he's going to ask for something. He's going to ask for something which basically depends on something else. So it's going to be all over the place. So the caching is going to be a little bit more difficult. Again, not that much difficult, and it's not that much different. Again, I would do the similar thing that I did here. All my endpoints, all my resolvers, I would send basically to services, and then again, I would cache all the service calls. And in that case, basically, I would have similar thing like I have here. Until I hit the services, user can go wherever they want to go. But once they hit the services, then again, I'm back in full control. So I can really cache it very good. So that's about the caching. Okay, but we all know that the APIs is usually much more. What about parameters, you know? Because again, like I don't want to ask every time for all the posts, right? I want, for example, for posts from certain author, I want things like that. So I need to somehow send parameter to basically in my request. Well, it's done exactly the same like I did it in mutation. Basically, mutation was, okay, I have a request and have parameters inside it. So that's simple. What about headers and cookies? Because again, for example, for some APIs that I built, we didn't send parameters through the URL. We were sending them through the headers. So it's a little bit more tricky, right? Well, in this case, what you need to do, at least in Java implementation, is create the custom context class, which is going to extend GraphQL context. And then you basically add your custom code, whatever you need there. In order to use it, in the servlet that I was using in the front, you're going to have override the method which is going to call create context, which is return basically taking request and response, sending back GraphQL context. In this case, then you basically from the request, you take the headers, you do whatever you want to do with them, you do the checks, whatever is needed, feed in basically your custom context, and send your custom context back. And that's it. And then if you want to use it somewhere along the way, in some method, in some resolver, after the arguments, oh, this is not going to be very visible. Everybody see the last line or? Okay, cool. You're going to add something like this, data fetching environment, and then you can just go to say environment, get context, and then you get basically your custom context. And then again, you're back in full control. You can do whatever you want to do. Okay, what about authentication? Because we all know that not all the APIs are completely open to the world, right? Sometimes we need to check credentials to see, okay, like, is everybody has the rights to see what they need to see? Well, in Java implementation, you're doing that using the custom context. That's it, basically, same thing. So, conclusion. If we put GraphQL on one side, and then we put all the basically requirements for a REST API, actually for the rest, let's look at it, how it goes. Client-server architecture, I would say yes, I showed you. Is it stateless? Well, yes it is, because again, server, if you build it in the correct way, server have no clue about the state from the client. Client needs to send all that's needed in request. Is it cacheable? Yes, it is. Layered system? Again, yes. The client have no clue if it's talking directly to the server or is going through multiple layers. Code on demand? Well, it was optional, so we can just skip it. And uniform interface? Well, the schema is definition of everything. Everything starts with the schema, everything ends with the schema, and the schema is going to allow us basically different parts of the system to develop independently. So yeah, I would say also true. So GraphQL is a REST. And that's, if you want more proof, basically I debugged a little bit of the HTML page that they showed you. And what actually does, it just calls the endpoint, GraphQL, send the post request. Inside he sends JSON, which says query. And this one is basically the query that I was writing all the time in the browser. It also has variables null, and that's it. And we get all the response. So GraphQL is REST. But does it then mean that we shouldn't be using it because we're using REST for a long time now? So like, why use GraphQL? Well, not really, because, oh yeah. Again, like this, if you're a little bit older, then you know what VSDL is, and this is one of the first impressions that I got about GraphQL, because again, everything is going according to the schema. The client takes the schema and then understand what it can ask for the client. But I would say this is much better than the VSDL days. Again, like, I would say you should use GraphQL or some other specification because you don't have very long meetings then. If you have a specification and a lot of questions are answered to you, you don't have to go into meeting and discuss about it. Like I said, for example, filtering the fields. Can we do it? Yes, we can. We don't need GraphQL for that one. But then what we need to do, we need to actually agree how are we going to do it. How are we going to actually request for the client to send us this information, and how are we going to process it? Then again, if it's only used internally, it's going to be slightly easier to align everybody. But if you have API which is public to the world, then you need to basically to the whole world explain, okay, this is how you need to do things in order if you want to take advantage of the advanced features. Like for example, if I want to embed author inside the post. With GraphQL, all these kind of things are already taken care of for us. So we don't have to think about it. We can just follow the specification and it's done deal. Again, traditional REST APIs were not really standing still all of this time. So you have a lot of other specifications like an Open API, RAML, Swagger, API Blueprint. Again, they're also very powerful and they can help you a lot in making the better code. But again, certain things that they're going to provide you basically they can't provide you all the things that GraphQL can. So it's basically a trade-off. What's your use case? What's going to benefit you the more? Again, one more thing that you should also take into account is the HAL, which comes from the K2S kind of thing, but for APIs, which idea is that your context is explorable. So again, like even if you don't know everything about your context, from one object you can go to another object, and that's something similar that GraphQL is also giving to you. Because if you remember that crazy query that I created, I started with the post, then went to the comments, then went to the author, then from the author I went below. So it's kind of similar to this one. Again, certain things you will get for free, certain things you will have to implement. All the code examples are on GitHub, so you can use them, play with them. Like I said, it's not really production code, it's basically just the code to demo some stuff. So you're using it on your own risk. Everybody got a picture? Cool. Okay. So, thank you.